beautiful listeners, welcome again to class. As you know, we are on a series of revision for my BFN students, and today we're going to be revising calculus. All right, calculus. Now, in this video, we're going to concentrate more on differentiation. All right, although we're going to be looking at differentiation and integration, in this video, we're going to be concentrating more on differentiation, and we're going to be looking at how we can use the rules such as the chain rule, product rule, and the quotient rule in solving some differentiation problems. All right. So now without wasting time, if this is the first time joining us, you're welcome to class. Don't forget to subscribe and also help us share our videos. Now before we proceed, differentiation can actually be represented by dy over dx. All right. Now, this dy over dx is known as the first principle. Alright. And this is gotten by differentiating just once. Just once. And then we also have things like the 2y over the x squared. Now, this simply refers to as the second principle. This simply, you can get the value by differentiating 2 times. Alright. And then so on and so forth. If we have the 3 over dy, the 4 over the xy. So it depends. What you have here tells you the number of times you differentiate the function that is given. Okay. And then what you need to know again about differentiation is that when you differentiate a constant, the answer is 0. So for instance, if I have, what's it called? Y is equal to 4. And then you are told to find dy over dx. Because 4 here is a constant, our answer is 0. It's as simple as that. When you differentiate a constant, the result is 0. Okay. And also, we also have a general formula for differentiating, which is if y is equal to ax raised to the power of n, then dy over dx becomes anx raised to the power of n minus 1. How did I get this? By using the power to multiply the coefficients. And then after we multiply the coefficients, we subtract 1 from the power. So this is the general formula we will be applying when solving differentiation problems. Okay, let's begin the class proper. So what you just need to do is to sit back, relax, listen, and then you understand how this works. So at least we're going to be solving 5 questions. 5 questions generally. 5 questions. So the first question says, if y is equal to 6x raised to the power 3 plus 4x raised to the power 2 minus 10x plus 9, come on, find dy over dx. All right, find dy over dx. So it's very simple. This is what we do. Dy over dx becomes, like I said, the power multiplies the coefficients, then you subtract 1 from the power. So 3 times 6 gives us 18, and 3 minus 1 gives us 2, so we are done with that. Plus 2 times 4 gives us 8, and 2 minus 1 gives us 1. There is no need to include the 1. Minus, now the power here is 1, so it means when we differentiate 10x, we are going to get 10. Why is it so? Watch. If you have 10x and then the power is 1, if 1 should multiply 10, we'll get 10. And if you should minus 1 from 1, you get 0. And according to the law of indices, 0 power law, anything raised to the power of 0 is 1. So if x raised to the power of 0 is 1, it means what do we have left? 10. So that is how I got 10 as my answer there. Okay, let's proceed. Now, I have plus 9. Remember we said from the beginning of the class, 9 here is a constant. So when we differentiate 9, what are we going to get? 0, because it's a constant. So this becomes the answer to that question. It's as simple as that. Alright. So let's go to question number 2. It says if y is equal to 4x raised to the power of 4 minus 3x raised to the power of 3 plus 6x raised to the power of 2 minus 2x plus 5. Come on, we are told to find the 3y over the x cubed. Okay, now we are told to find the third order derivative, or you can simply call it the third principle. How do you get this? It's very simple. It means differentiating 3 times. And don't forget, before you can get to this, you have to get the y over the x, then the 2y over the x squared before you now get this order. So let's begin the question. Let's start solving. So it means the first one I'm going to solve for now is dy over the x, which is actually the first order or the first principle. So let's differentiate this function now. 4 times 4 gives us 16. 4 minus 1 gives us 3. 3 times 3 gives us 9. 3 minus 1 gives us 2. 2 times 6 gives us 12. 2 minus 1 gives us 1. Minus, if we differentiate 2x, like I said, because the power is 1, it means our coefficient is the answer. So we're going to get 2, and if I differentiate 5, I'll get 0. Now this is not the answer because this is the first order. But we are to look for the third order derivative. So here, let's get to the second order now, which is the 2y over the x squared. Okay. And let's proceed. So for us to get the second order, we need to differentiate the first, which we just got. So 3 times 16 now, we are going to be getting 48. X and 3 minus 1 gives us 2. 2 times 9 gives us 18. X, 2 minus 1 gives us 1. Plus, if we should differentiate 12x, we'll get in 12. And if we should differentiate 2, we'll get in 0. Now, this is also not the answer because we're looking for the third order. So to get the third order derivative now, which is the 3y over the x cubed, we now differentiate the second principle. So 2 times 48 gives us 96. X, 2 minus 1 is 1, minus, if I should differentiate 18x, I'll get 18, and if I should differentiate 12, I'll get 0. So this becomes required that we are told to solve for. Alright, so not this first one, not the second, but the third one. So you see, it is as simple as this. Okay, let's go to question number 3. Question number 3. You know, we have to be fast so we can cover lots. Question number 3. Okay. Okay. Now imagine you have a question like this. Example 3. Imagine you have a question like this. If y is equal to, let's say, okay, 6 over x raised to the power 3, alright, plus 2x raised to the power 4 minus 10x raised to the power 5. Come on. Now we are told to find the y over the x. Imagine we have a question like this. Now, we don't have a problem with this. But we have a problem with this. Why do we have a problem with this? Because the x is at the denominator. And now you can't differentiate because the x is at the denominator. So the first thing we're going to do is that this x raised to the power 3 will bring it up to the numerator. Now when x raised to the power 3 goes up, it becomes x raised to the power negative 3. So now, so at this point we are not differentiating. You can't write the y by the x because we are not differentiating. So here we are still going to write y. Right. So when x raised to the power 3 goes up, it becomes 6x raised to the power minus 3 plus 2x raised to the power 4 minus 10x raised to the power 5. Now, no more fraction. So now we can differentiate because there's no more fraction. So when we do this, let us solve now. The y over the x. So let's differentiate now. Minus 3 times 6 gives us minus 18. Minus 3 minus 1 gives us minus 4. You have to minus 1 after you've multiplied. Plus 4 times 2 gives us 8. And 4 minus 1 gives us 3. Alright. Now, minus 5 times 10 gives us 50. And 5 minus 1 gives us 4. Now, you won't leave your answer like this. Why? Because initially, in the original question, our x was at the denominator. We were the one that took it up. So what do? We bring it back again. So what do we have now as x? And here we have x raised to the power minus 4. Now we will bring down x raised to the power minus 4. The minus goes away and becomes a positive sign. So what do we have left? Here will now be left with just what now? Minus 18. Because the x is coming down. So what will now be down? X raised to the power positive 4. Are you there? Plus 8x raised to the power 3 minus 50x raised to the power 4. This becomes the answer. It's as simple as that. It's as simple as that. Alright. So now let us proceed to example number 4. Example number 4. Example number 4. Now, example number 4 has to do with chain rule. Let's involve our rules now. Chain rule. Now, you can call it chain rule, or you can call it the function of functions rule. The function of functions rule. How do you solve differentiation problems involving chain rule? First of all, how would you even know that the question needs chain rule to be solved? Now, this is what you see. Every chain rule question has one function. And the name of the function is u. Alright, every chain rule has one function, and the name of that function is u. And chain rule has its own formula. It's like its own formula. And what is the formula for solving chain rule? Which is dy over dx is equal to dy over du times du over dx. Now, this is the formula for solving chain rule. It's very important that you know this. It is very, very important that you know this. So now, under chain rule, we are going to be solving 2 examples. All right, 2 examples, so that you get a better understanding about the explanation. So let's go. Example number 1. Now, example 1 says, if y is equal to 6x plus 5 raised to the power of 6, find dy over dx. 6x plus 5 raised to the power of 6. We have to find dy over dx. Don't forget we said dy over dx is referred to the first order derivative or the first principle, which means we are only going to differentiate just once. Now, I'll be teaching you 2 methods, the longer part and the shorter part. So it depends on what you want to apply during your exam. First part is the long part. How do we solve using the longer part? This is what we do. Remember I told you that in every chain rule question we have just one function. Listen to me. In every chain rule question we have only one function. Now, how do you know the function? The function is the expression inside the bracket. That is the function. And we said that the name of that function is what? U. So it means in this question, my u is what? 6x plus 5. Simple. So let's start. Solution. U is equal to 6x plus 5. Now, if u is equal to 6x plus 5, what is now y? Y now will no longer be 6x plus 5 raised to the power of 6. Rather, y will now be u raised to the power of 6, because 6x plus 5 now is now what? U. So here becomes u raised to the power of 6. Simple. Are you with me? Now, let's see. In the first one here, we have u and ox. We have u and ox. So what are we going to do? We are going to find du over dx. You see, and the reason why we always solve for dy over dx is because in the question we have y and x. So it means if we have p and q in the question, we are not going to solve for dy over dx, rather we're going to solve for what? dp over dq. Simple. So the variable tells you what you are differentiating. You don't tell yourself what to differentiate. Now let's look. If we should differentiate this function now, if I differentiate 6x, I'll get 6. If I differentiate 5, I'll get 0. So it means du over dx is 6. So the next one we're going to look at now is, what are the 2 variables here now? Y and u. So I'll look for dy over du. We all know that we only have u raised to the power 6 here. So if I differentiate u raised to the power 6, what will I get? 6u raised to the power 5. How? 6 multiply 1. There's 1 here. So 6 times 1 is 6. 6 minus 1 is 5. So now that I've got it, dy over du and du over dx, what do we do next now? We'll apply the formula for chain rule, which says dy over dx is equal to dy over du times du over dx. Alright, now let's go. When we solve for dy over du, what did we get? 6u raised to the power 5. So here becomes 6u raised to the power 5 times. When we solve for du over dx, what did we get? 6. Are you with me? Yeah. So automatically, we're going to have this. 6 times 6 gives us what? 36. So here becomes 36u raised to the power 5. But this is not how you will leave your answer, because why? U has an expression. And what is that expression? 6x plus 5. So it means what we now do, we now have to substitute back 6x plus 5 into our final answer, which becomes 36 into bracket. U now is 6x plus 5, all raised to the power of 5. This becomes the answer. This becomes the answer. It is as simple as this. So class, I said I'm going to be teaching you 2 methods. What is the other method? The other method is simply getting your answer directly from your question without solving anything, without using formula, without using nothing. And how does that work? This is it. The question originally was y is equal to 6x plus 5 raised to the power 6. Now this is how it works. Answer straight up. Let's get our answer once. Now we are going to differentiate our u. Remember we said u was 6x plus 5. So we're going to differentiate everything inside this function. Inside the bracket rather. If I differentiate 6x, I'll get 6. Plus, if I differentiate 5, I'll get what? 0. So 6 plus 0 will give us what? 6. That 6 that you now get, now you use to times your power. Anything you have your power. Now our power here is what? 6. So 6 times 6 gives us what? 36. Then you will copy back the question, which is what? 6x plus 5. Then you minus 1 from the power, which is 5. Which is the same answer that we got. Simple as that. You see, it's that simple as that. How did I do this again? I differentiated everything inside there. I got 6. I used 6 to multiply 6, which is the power, to get 36. Then I copied back the question here, and then I minus 1 from the 6, and then I got what? 5. That gave us our answer. Super. 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 So now, let's go. Like I said, we are going to be solving two questions just to make things easier for us to understand. All right, 2 questions. Okay, example number 2. Example number 2 says if y is equal to 10x raised to the power 3 plus 4 raised to the power of 7. Come on, find the y over dx. You will mean now. Find the y over the x. Find the y over the x. Alright, let's proceed. Again, the 2 methods we're going to apply here. So let's see how we're going to get the answer. So here, applying the first method, we said our u is what is in the bracket. And what is in the bracket here is 10x raised to the power 3 plus 4. So it means u is equal to 10x raised to the power 3 plus 4. Alright. So now if u is 10x raised to the power 3 plus 4, it means our y becomes u raised to the power of 7. Simple. So what did I say we differentiate here now? The u over dx. So here becomes the u over dx. Now if I differentiate 10x raised to the power 3, I will get 30x raised to the power 2. And if I differentiate 4, I'll get 0. So there's limit to that. So let's come here now. We have y and u. So what do? Differentiate the y over the u. If I should differentiate u raised to the power 7, what would I get? 7u raised to the power of 6. So what did I say we do next now? Introduce our formula. Now our formula says the y over dx is equal to the y over du times du over dx. You see, it's as simple as that. Now, our dy over du is this. 7u raised to the power 6. Multiplied by du over dx is 30x raised to the power 2. Alright, 30x raised to the power 2. So what do we do now, class? 7u raised to the power 6 times 30x raised to the power 2 will give us 210x raised to the power 2u raised to the power of 6. Yeah, it's as simple as that. But don't forget we said u is 10x raised to the power 3 plus 4. So here it becomes 210x raised to the power 2 into the bracket of 10x raised to the power 3 plus 4 all raised to the power of 6. Simple. That is how we got our answer. Now like I said, we can also apply the shortcut method to get our answer straight. And how does that work? We simply, the question was y equal to 10x raised to the power 3 plus 4 raised to the power of 7. So what did I say we do? Differentiate everything inside the bracket. If I differentiate 10x raised to the power 3, I'm going to get 30x raised to the power 2. And if I should differentiate 4, I'm going to get 0. So don't need to write it 0. So this 30x raised to the power 2 will multiply 7. Now 30x raised to the power 2 multiplied by 7 will give us 210x raised to the power 2. Alright. Now copy back the question, which is 10x x raised to the power 3 plus 4. Then minus 1 from here, which is 6. You see that we got the same answer. The same answer. Alright, with these two examples, you will be able to solve problems on chain rule. So the next rule we are entering now is the product rule. Alright, is the product rule. So let's see how the product rule works. Let's see how the product rule works. Now, product rule is made up of two functions. And these functions are u and v. These are the two functions, u and v. Now, because of the word product, it means the functions now, which are the u and v, are actually multiplying each other because product means multiplication. It's as simple as that. Product means multiplication. So we're going to be having two functions here that are multiplying each other. So we'll also we'll be looking at two examples. So let's see what we can do. Example number 1. If y, I have to give you first the formula before we proceed with the example. Now, product rule also has its formula, and the formula is dy over dx is equal to u dv plus v du. All right, u dv plus v du. And what does it mean? U dv means hold u, meaning don't touch u, but differentiate the function v. All right, and v du means don't touch v, but differentiate the function u. Simple. Simple. So when you say don't touch, it means hold is constant. Don't touch. Don't touch. So let's use this formula now to solve some questions. Example 1. It says if y is equal to 4x raised to the power 3 brackets 2x plus 4, come and find dy over dx. All right, find dy over dx. So let's see how we can solve this problem now. Solution. Now you're going to see that we have two functions here. One outside the bracket, another inside the bracket. Now the one outside the bracket is the u, and the one inside the bracket is the v. And you see the bracket sign here represents what? Times. So it means these two functions are timesing each other. That is the only reason why you can apply product rule. Okay, now that we know our u and then we know our v, so what we're going to find first, we're going to get our u dv, and then we're going to get our v du. So bringing the formula, dy over dx becomes, now we said u means hold u, don't touch it. So if we're not touching u, it means we're going to write 4x raised to the power 3 down. We're not touching it. So I'm going to write 4x raised to the power 3 bracket. What am I differentiating now? V. What's my v? 2x plus 4. If I differentiate 2x plus 4, I'll get 2. Now, plus, you have to follow the formula. What am I holding now? V. And what's v now? 2x plus 4. But what am I differentiating now? U. What's my u? 4x raised to the power 3. If we differentiate 4x raised to the power 3, we're going to get 12x raised to the power 2. So now that we have done that, what do we do? Let's open the bracket. 4x raised to the power 3 times 2 gives us 8x raised to the power 3. And 2x plus 4 raised to 2x plus 4 times 12x raised to the power 2 becomes this times this times this. Multiplies everything inside the bracket. So 2 times 12 gives us 24. X times x squared gives us x raised to the power 3 according to the law of indices. Plus 4 times 12 gives us 48. Then we'll bring our what? Our x squared. Now we can't leave our answer like this because why something can be done here. What can be done? These two can be added. Why can they be added? Because the powers are the same. So I will just say 8 plus 24. 8 plus 24 gives us 32. So our final answer becomes 32x raised to the power 3 plus 48x raised to the power of 2. That is the answer to that question. That is how you can actually apply product rule formula. Alright, that is it. So now let's go to the next example. Like I said, two examples, so we can understand product rule better. Alright, so we can understand product rule better. Okay, I'll see that this second example is somehow complex. Let's see. Imagine we have a question like this. Example 2. If y is equal to 4x raised to the power 2 bracket 3x plus 5 raised to the power of 3. Imagine we have a question like this. 3x plus 5 raised to the power of 3. And then we are told to find the y over the x. Yes. Now, if you look very well, you can see chain rule inside. You can also see product rule inside. Why is it product rule? Two functions multiplying each other. Why is it chain rule? This one alone, this bracket and this power alone is what? Chain rule. So, but what formula are we going to apply? Product rule, because it's product rule we are using first. Now, using the formula which says u dv plus v du, let's see what we can do. Solution. dy over dx now becomes, now we say we should hold u. Now our u here, so this is u now and this is v. Now our u is 4x raised to the power 2. We are holding this, we are not touching it. But we are differentiating v. Now watch me. My v alone is what? Chain rule. So I'm going to use the shortcut formula to solve the chain rule. So if I differentiate everything inside, I'm going to get 3. 3 times 3 gives us what? 9. Are you there? Then you open a bracket, then copy back the, what's it called? Everything inside the what? Copy back everything inside the brackets. 3x plus 5. Then minus 1 from the power 2. Alright. So here we have 2. Okay, it's as simple as that. What's it called? Differentiate the function inside, you get 3. 3 times 3 gives us a 9. Copy back 2x plus 5, then minus 1 from the power, which is what? 3. And that gives us 2. So we have done u dv. Plus, let's go to v now. V now is 3x plus 5 raised to the power 3, constant. So I'll give that here. 3x plus 5 raised to the power 3 is constant. What are we differentiating class now? We're differentiating u. And what is our u? 4x raised to the power 2. So if we differentiate 4x raised to the power 2, we are going to get 8x. So class, what do we do? Now, without wasting time, let's open the brackets. Now, 4x raised to the power 2 multiply 9. Now, if 4 times 9 gives us 36. Alright. So now, if 4 times 9 is 36, what will that be here now? 36x squared into the bracket of 3x plus 5 raised to the power 2 plus 8x multiplied by this guy will still give us 8x into the bracket of 3x plus 5 raised to the power of 3. That becomes our answer. Simple as that. That becomes our answer. Simple as that. So class, you see, sometimes it can be just product rule, it can be just chain rule, and it can be also the combination of product and chain rule. So this brings us to the end of product rule, and we are entering the last part of our video today, of our teaching today, quotient rule. Alright, let's go to quotient rule now. Quotient rule. Now, quotient rule has to do with division. Quotient rule. Now, the formula for quotient rule is y over dx is equal to v du minus u dv all over v squared. V du minus u dv over v squared. This is the formula for solving for solving quotient rule. So also we're going to be solving 2 questions and then we are done with today's class. Example number 1. If y is equal to 4x plus 5 over 2x plus 2, find the y over the x. Right. You see, quotient rule questions are always, always comes out like fraction, because the word quotient means division. And for division to be found, it means we're going to be working with fractions. Alright. So now, what do we do? Quotient rule also has 2 functions which are called u and v, just like product rule. But the difference between product rule and quotient rule is clear. Product rule says the 2 functions multiplies. Quotient rule says the 2 functions divide. That's the 2 difference. So it means here my numerator is u and my denominator is v. Alright. So now let's solve. Solution. Now according to the formula, dy over dx becomes, now v du means hold v and differentiate u. So my v now is 2x plus 2. Now we'll differentiate u. What's my u? 4x plus 5. If I differentiate 4x plus 5, I'll get 4. Alright. minus, now hold u. What is my u now? 4x plus 5. Now what am I differentiating now? V. Alright. Now what's my V? 2x plus 2. If I should differentiate 2x plus 2, I'll get 2 all over. Now the denominator says V squared. V squared means it means don't differentiate, it's just V squared. So what's my V now? Here becomes 2x plus 2 all squared. Simple. That is it. Now what do we do now? Let's open the bracket. Here becomes 4 times 2x gives us 8x plus 4 times 2 gives us 8. Alright. Minus, watch me now, watch me please. 2 times 4x gives us 8x. Look at what you will do. Minus must multiply the sign here first. Minus times plus will give us what? Minus. Then 2 times 5 gives us what? 10. If you fail to multiply this, then you have failed the question. All over. Class, you don't touch the denominator. The denominator remains 2x plus 2 raised to the power 2. You don't touch. So now let's solve the numerator now. 8 cannot be added to 8x because why 8x is carrying x. But I can do 8x minus 8x. Now 8x minus 8x is 0. So what do we have left now? 8 minus 10. 8 minus 10 actually is what? Minus 2. So our final answer to this question becomes minus 2 over 2x plus 2 all squared. That is the answer to the question. You see, you don't work with the denominator. You only work with the numerator. So this becomes our answer to question number 1 involving quotient rule. So let's go to example 2 and then we'll call it a day. Alright. Okay, question 2 says if y is equal to 10 over 9x plus 5, find the y over the x. Aha! Again, 10 is my u, 9x plus 5 is my v. Applying the formula which says v du minus u dv over v squared, we're going to have this. The y over the x becomes, now hold v, my v is 9x plus 5. Differentiate u, what's my u? My u is 10. So if I differentiate 10, what will I get? 0. That's my 0 there. Minus, now hold u, what's my u now? 10. Now what am I differentiating now? V, what's my v? 9x plus 5. If I actually differentiate 9x plus 5, I'll get 9 all over, my v squared now becomes 9x plus 5 raised to the power of 2. Alright. So now let's open the bracket. Here it becomes 0 times everything here gives us 0. Minus 9 times 10 gives us what? 90 all over 9x plus 5 raised to the power of 2. So now what do we do? 0 minus 90 gives us minus 90 over 9x plus 5 raised to the power of 2. That becomes our answer. So class, you see, this is how you can simply apply chain rule, product rule, and quotient rule in solving differential calculus. So we'll meet again in our next class. Keep on watching Jeff Nano Mathematics class. If this is your first time joining us, you're welcome. Don't forget to subscribe. Don't forget to help share our videos, and also you can leave your comments how you feel about the class in the comment section. Till we meet again. Bye for now.